Okay, starting the second video here. We were just about to graph this complex number on a complex plane. The complex plane has an x-axis and it has an imaginary axis. This first part is your real part, or your x part, so you're going to go over -2. This part right here is your imaginary part, so you're going to go down 1. So this is -2, -1, and then you're going to draw a line from that point to the origin. That is how you would graph that on a complex plane. We also learned that it has a z-score, okay? Now the z-score is going to give you this, the square root of this squared plus this squared. So this is going to have a value of the square root of 5. Now that's also what you would get if you had done Pythagorean theorem on that. So that is your score of V, of the Z, if you will. I think I did, yeah, okay. We also learned to put this in polar form, okay? This z-score is also going to be your r. So your r is equal to the square root of 5, but then I need to find my angle. Now remember, your polar form looks like this. R times the cosine of theta plus I times the sine of theta. And you are learning to find that and that. So I just found the r, so that's the square root of 5. Now I'm going to find the angle, same way I've been finding the angles, the inverse tangent of -1 over -2. Now if they're both negative, you know it's going to be in the third quadrant. So when I do the inverse, and I'm going to have it in radians, do the inverse tangent of that, I get 0.46, okay? 0.46 is not in the third quadrant, it's in the first quadrant. So I would have to add pi to that, giving me a value of 3.60. So that is what's going to go over here. I have a 3.60 plus I times the sine of 3.60. Now we did notice that there's a shortcut on writing that. If you want to write it like that, that's acceptable. Understand that that and that are the same thing. All right, let's graph and express in a complex form. So in other words, they give me this, and I have to express it in a rectangular form, but I also have to graph it. So we are still in section 9.6. Let's say you start out with this. You have 4 times the cosine of pi over 3 plus I times the sine of pi over 3. And they say graph it and turn it into a complex form. This is a complex polar form. To graph it, it's relatively easy. I just have to find where the point 4 pi over 3 is. Okay, so I need 4 rings. And that line right there is your pi over 3. So it would be this point. So when I graph it, it is the line from the pole to that point. So that is the graph of that equation. Now, to turn it back into rectangular form, it's actually relatively easy. All I have to do is put a value there. The cosine at pi over 3 is 1/2. The sine at pi over 3 is the square root of 3 over 2. So I'm distributing my 4, so that's going to be 2 plus 2 on the square root of 3. Don't forget to put the I at the end to put it in the proper form. All right, section 9.7, we began to multiply and divide by these. And if you remember, there's a particular form or pattern that you do in order to do that. So let's say that I start out with 2 times the cosine of pi over 2 plus I times the sine of pi over 2. And I'm multiplying here times 4 times the cosine of pi over 3 plus I times the sine at pi over 3. And you could do the shortcut form on those two. All right, first thing I do is I multiply the r's. So that's going to give me an 8. Then it's 8 times the cosine of pi over 2 plus pi over 3 plus I times the sine of pi over 2 plus pi over 3. All right, so I have to combine those, so I have to have a common denominator. When I do that, I'm going to get 5 pi over 6. So I'm going to do that out. So the cosine at 5 pi over 6 is negative square root of 3 over 2. The sine is going to be positive 1/2 because I'm going to be in the second quadrant. And I'm going to actually multiply here. So it's going to give me negative 4 on the square root of 3 plus 4i. And that is going to be my answer to the multiplication of that. All right, let's do a division one. Different pattern. Say I have 21 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6 divided by 7 times the cosine at 4 pi over 3 plus I times the sine at 4 pi over 3. All right, to divide, I'm going to divide the r's. So I have 21 divided by 7 times the cosine of 7 pi over 6 minus 4 pi over 3. So this time you're subtracting plus I times the sine of 7 pi over 6 minus 4 pi over 3. So I have 3 times the cosine, and when I subtract this out I get a negative pi over 6 plus I times the sine of negative pi over 6. The value there is the square root of 3 over 2, and the value for the sine of negative pi over 6 is negative 1/2. So when I multiply here, I get 3 on the square root of 3 over 2 plus negative 3 over 2i. And that's going to be my final answer. All right, the last section was on finding the powers and the roots. And they are all done the exact same way with the same pattern. So we'll do a power first. Let's say I have negative 1 plus the square root of 3i cubed. The very first thing I have to do is change that into polar form. So r is going to equal 1 plus 3, because it's that squared plus that squared, which is going to give me the square root of 4 or 2. The angle is going to be the inverse tangent of the square root of 3 over negative 1. Okay, so that's going to be in my second quadrant. That is actually going to give me a value of 2 pi over 3. So now I write it as a polar complex form. So I have 2 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3, and it's raised to that power. All right, the pattern for doing that is I raise the r to that power and I multiply the theta by that power. So I have 2 cubed times the cosine of 3 times 2 pi over 3 plus I times the sine of 3 times 2 pi over 3. Obviously that's going to give me 2 pi, so I have 8 times the cosine of 2 pi plus I times the sine at 2 pi. At 2 pi, my cosine is 1, so I have 1 plus, and the sign there is 0. So essentially my answer is just 8. If you want to do 8 plus 0i, you can do that. We also did ones with roots, and we did negative ones as well, but they're all done the exact same way. Let's say I have the cube root of 64i. Okay, that is the same thing as saying 64i to the negative, or to the positive 1/3 power. That's how you would do a root. So again, the first thing I got to do is change it into polar complex form. So I have the square root of 0 squared plus 64 squared, which is going to give me a value, and put it in here, of 64. So that's going to be my r. My theta is going to be the inverse tangent of that, of course, is my sine. So basically, it's where my sine has value, positive value, and my cosine has 0 value. Well, you know by your unit circle that that's pi over 2. So I write it as 64 times the cosine of pi over 2 plus I times the sine of pi over 2, and it's raised to the 1/3 power. So I'm going to go back, and I'm going to raise my 64 to the 1/3 power, and I'm going to multiply each of those. So 64 to the 1/3 power times the cosine of 1/3 times pi over 2 plus I times the sine of 1/3 times pi over 2. And so I take the 64 to 1/3 power is 4, so the cube root of 64 is 4, times the cosine of pi over 6 plus I times the sine of pi over 6. And that's going to give me 4 times, the cosine there is the square root of 3 over 2. The sine is 1/2, so I'm going to do 2 on the square root of 3 plus 2i. And that's going to be my final answer. All right, your review homework, getting ready for the test, is page 608 through 610, 12 through 64 even. And you should have also received a review sheet with this video.